In this video, we're going to bring together everything we've learned so far, from document loaders and text splitters to embeddings, vector stores, and retrievers, and use them to build something real. Imagine being able to ask questions directly about the content of any YouTube video without manually watching or scrubbing through it. That's exactly what we're going to do. We'll start by pulling the transcript of a YouTube video using the YouTube Transcript API. This gives us all the spoken text, which then becomes the foundation of our knowledge base. Now, we'll use the recursive character text splitter to break that long transcript into manageable chunks, so our system can process and retrieve information efficiently. Then comes the magic. We'll convert those chunks into embeddings using a HuggingFace model and store them in a FAISS vector database. This allows our system to search and retrieve content that's semantically related to any questions we ask. Once that's done, we'll turn FAISS into a retriever, which will find the most relevant parts of the transcript related to our query. Finally, we'll use a Gemini Flash model, Google's powerful language model, to analyze that content and generate an accurate transcript-based answer to our question. In short, we're transforming a YouTube video into an intelligent, searchable knowledge source. By the end of this video, you'll understand how all the individual LangChain components like loaders, splitters, embeddings, retrievers, and models come together to create a fully functional question answering pipeline powered by a real video content. So let's go to the implementation. So I'm going to create a new folder again. Let's call this rack systems. And inside this, I'm going to create a new file, YouTube_rack.py. Okay, first of all, I'm going to pull up YouTube Transcript API, import YouTube Transcript API and transcripts disabled. We'll need to install this library here because once I'll try to run this, so we'll need to install YouTube Transcript API. So let me just do pip install YouTube Transcript _API. Okay, then I'm going to import recursive character text splitter here. After this, embedding from our HuggingFace models. Then we'll import our model. I'll also import the prompt template. Then I'll import the vector database. And then finally, to load our credential, I'll import load.env. So step 1 is indexing or our document injection. So I'll take a video ID, and for video ID, I'm going to take my own YouTube video here somewhere. Let me also load this credential and let's go to the video ID part. Okay, so here is our video on like building a RAG pipeline, which we did a couple of days earlier in video number 17. So I'm just going to copy this particular video ID from the URL and then paste it in my code. Okay, so this is going to be my video ID. Then what I'm going to do is I'm going to try and then I'm going to initialize an object of YouTube API or YouTube Transcript API, and then I'm going to pull my transcript here. So yt_API dot fetch, my video ID will be my video ID, and then the language of the video is English. I want transcript in English. Then I'm going to flatten the transcript to plain text. So for this, what I'm going to do is transcript equals to dot join chunk dot text for chunk in transcript list. We'll also put an exceptions here. So if transcripts are disabled, then we'll say no captions available for the video. Okay, so this is step 1. We'll move to step 2. In step 2, we'll do indexing, which means our text splitting. So for that, we already have our splitter here. So let me initialize the object of the splitter. So splitter equals to RecursiveCharacterTextSplitter. I'm going to define a chunk size of maybe 1000, and then a chunk overlap. Okay, we'll not do 1000. 1000 is too long. So we'll do a chunk size of 300, and then a chunk overlap of 50. And then I'm going to use the splitter to split my text here or split my transcript. So create documents, transcript. If you want to see how many chunks we've broken it down into, so let's see if we can indeed extract the captions or transcript from our video or not. So let me run this. Okay, so we have 33 chunks. We could extract the transcript from our video. So let's go to step 3. The step 3 is embedding generation and storing in vector database. Okay, so embedding model will be used from HuggingFace Embeddings, and then the model name is sentence transformers all mini LM L6 v2. The model I found it from our HuggingFace library. Let's also initialize our vector store. So vector store is done using FAISS. So from documents, chunks, and then embedding equals to embedding model. Okay, so next is retriever. So I'm going to create my retriever from my vector store as a retriever, and then the source type is going to be based on similarity, and then search keyword arguments. Let me do this again. So search underscore keyword arguments is equal to the top, let's say, 2 results here. Okay, let me design my prompt using my prompt template. So in case of prompt template, let me define my template here. So let's provide you are a helpful assistant answer only from the provided transcript context. If the context is insufficient, just answer I don't know. And then let me add a line break and then mention context is equal to context, and question, another line break, question is equal to question. Okay, so this will be my template here. I don't think I need to put an F string, so let me remove this. So input variables are context and questions. Context and question. Okay, so this is done. Now let me devise my question here. What is the video talking about? And then we'll also join a context text. So context text is going to be joined from let's do this, /n dot join dot page underscore content for doc in retrieved docs, and then retrieved docs is going to be retriever dot invoke question. Okay, so after that I'm going to create my final prompt. So final prompt equals to prompt dot invoke. I need to pass two variables. One is the context, which I can provide from context text, and then the other is the question, which I can provide from my questionnaire. And finally I can invoke my model. So model dot invoke final prompt. I've defined my model, right? Okay, I've not defined my model, so let me also define my model here. So model equal to chat Google generative AI, model equals to Gemini 2.5 Flash model, and then print answer dot content from here. So let me run this and then see if we can actually get the answer from our generated transcript or not. Let me remove this print statement for now and then run it. I missed a comma. Let's see. Yeah, I should have provided a comma here at the end of the text. So let me run it again. It will take some time for transcript generation as well as the embedding model loading, and also it will take some time for the retriever to work here. So at first the model is being downloaded. I think I've already used this model earlier. I might have changed something here. Let me check. Okay, so yeah. Okay, so model was downloaded. So the video is talking about using embeddings to make a model retrieve and reason over real data. It will build a simple retrieval algorithm generation. Okay, it works. In fact, we're talking about the FAISS model in that particular video, and then it works. So I'll pass something that is not present in the context. So I'll pass this question here. My question will be, does the video, or like, what does What does the creator say about Brazil in the World Cup football? I don't think the context for this is present in the video, so the model should say that it simply doesn't know about it. Let me run this again. It would be efficient to just store this transcript locally once it is downloaded, so that every time the transcript fetching part is not done, as well as the vector store can also be stored. So as you can see, for this question, what does the creator say about Brazil in the World Cup football? It simply says, I don't know, because that particular context is not present in our transcript. So this is it. We have successfully implemented a YouTube transcript knowledge base, and then from that created a retrieval augmented generation system answering our particular question. So I hope it runs on your end too. If you have any questions, feel free to comment down below and I'll try to help you out. And I will see you in the next video.